What if good engineering still leads to bad outcomes? In a world where technology is accelerating faster than most industries can adapt, engineers are often caught between innovation and impact. We build the systems, but do we always understand the consequences? Today's guest is Raj Aseervatham, President of Engineers Australia, with decades of experience across mining, energy, ESG, and infrastructure. Raj brings a system-scale view of engineering and a belief that our technical decisions must keep pace with our social, environmental, and economic realities as they take shape. This episode explores fast-moving technologies from AI to material science are just reshaping not what we can build, but how we lead. Raj shares how a turning point in his career shifted him from problem-solving to perspective-taking, and why leadership now demands more than just technical excellence. So the question we're asking is this: if engineering is evolving at the speed of tech, how do we evolve our mindset just as fast? Welcome to the Structural Intelligence Podcast, the show where we explore the intersection of engineering, technology, and innovation. I'm your host, Owen Keenan, structural engineer, entrepreneur, and tech enthusiast. Each episode brings together innovators, experts, and thought leaders who are pushing the boundaries of what's possible in engineering and technology. Through deep conversations and practical insights, we explore how new tools, techniques, and mindsets are reshaping our industry. We hope you enjoy this episode. So Raj, welcome to the show.
Thank you, Owen. Great to be here.
No, it's great to have you, and great to welcome you over in Brisbane there. So I've just gone through, I guess, a little bit of an introduction, but I'd love for you to introduce yourself.
Sure. Look, I came to Australia as a migrant when I was 18, and I spent most of my life in Africa. So I did most of my STEM schooling, if you like, around Nigeria, Ghana, Zambia, Malawi, before we finally migrated to Australia. When I came here, I wanted to be an engineer. I knew that from a very early age. So, my background was because we'd been in developing countries around Australia, I saw the impact of engineering at scale. I saw how thousands of lives were changed by engineering, such as water, sewerage, electricity, and so on. Simple things that we take for granted. So it was very much in my wheelhouse to become an engineer. I hadn't actually thought of anything else. So so that's kind of my origin story, if you like, to Australia. Rocked up here to the University of Queensland at the age of 18, and that's it, engineering career from there.
Yeah, wow. That's and I guess sort of as you've gone through your career, what are some of the roles you've had, and what are some of the things that have, I guess, led you to the place where you are now?
I spent the first couple of decades of my life in mining with some of the large mining companies that often make the headlines. And after that, I was a consultant. I started my own consulting business about 24 years ago, and that still operates in London. After that, I came back to Australia, and I spent 10 years in the energy industry with Origin Energy as the head of sustainability before moving to a non-executive career. So it's always been sort of in heavy engineering that I've had my basics, and now into sort of non-executive directorships.
Yeah, no, that's great. And I'm sure you've had opportunities for great leadership in that sense, being able to lead teams or to lead policy and other things like that. And especially as your role with Engineers Australia right now as the president too. Very much so.
I think the reality is that the world has been changing at such a pace that the opportunity for leadership presents itself quite often. And particularly in engineering-heavy industries where the pace of technology change often outpaces what you're learning, the ability to be a leader, or the potential to be a leader is always there. It's always evolving.
And I really like that sort of, thank you for going through your span of your career in a way, because it's a great backdrop to the discussion that we were going to have today, because I think in a lot of ways, engineering starts from nuts and bolts, but then the leadership and the technology piece, they all play different parts, and there's obviously other factors as well. You mentioned that you grew up in Africa and you saw some of the different infrastructure things there, and look, as we talked before, you spoke about a turning point early in your career where in that moment you sort of, I guess, it changed your thinking as an engineer. Would you be able to, I guess, take us back to that and give us a bit of bit of a story or give us a context on that point?
Sure. I'd been an engineer for about 9 or 10 years at that point. So I was, in that sort of age where you become a chartered engineer. I hadn't yet got my chartered engineering at that point, but I was finishing my PhD and I was working on mine sites at the same time, and I was working on a mine. And it's worth sort of giving you a little bit of context. On a mine, the leadership team is effectively a bunch of engineers. You've got mining engineers, process engineers, mechanical engineers, civil engineers, geotechnical engineers. You've got the whole works, electrical engineers. I was on that mine, while I was working on that mine, something happened with, we had some issues with the community, and a decision was made to hire some mercenaries to maintain control of the issues that were happening in the communities. And I remember they turned up with aviator sunglasses and quite the attitude. I left the organization shortly after that. I was quite disheartened, I think, by the decision making that had privileged a large engineering asset over the lives and the livelihoods of people around that. So, still young enough to reinvent my career, I guess, but it was at that point that I sort of turned my attention to a broader context of engineering, not just the technical, not just the project delivery.
Yeah, that's so insightful. I think we go about our day or our projects or we are doing things as engineers where we're building the infrastructure or we're doing a function of resources or other things like that. And one thing that you sometimes forget is, and in your case, this was a social aspect to our impact as engineers. And all right, so the mining or the other things would be going in accordance to plan, in accordance to program, in accordance to budget, and all those other things. But this different aspect of thinking, which when we really boil it down, that there are things that are important. And I think as we talk today, I'd love to address some of those things. One is a social aspect, but there's other things such as your environmental lens or your technology lens or other things like that too. One thing that really struck me as we talked before this is you said that sometimes good engineering can still create bad outcomes, which is quite an interesting thought. So would you be able to expand on that?
Sure. Look, I'll give you my biggest example, and it's one that stares us in the face every day. The Industrial Revolution basically accelerated the pace of engineering in all forms, right? From civil through mechanical, electrical, anything you can think of. The Industrial Revolution sort of sparked that engineering explosion. And as a result of that explosion, all of which was innovative and fantastic for the world, had a dark outcome, and we're facing that at the moment in the threat of climate change, and the direct correlation between great engineering or enabling engineering and the unintended consequence of climate change is one that you can draw with a very straight line. So that is an example where good can sometimes shield or hide from us the underlying threat or bad that may emerge.
Mm. And I guess that leads to sort of thinking about some of those global challenges and other things like that. And they are complex, I'd certainly say. As we sort of go into that, engineers sometimes find ourselves in different roles and in different things that we need to do, and often in leadership. And you said that engineers sit at the center of some of the world's biggest problems. I'd love to just sort of drill down into that and break that down a little bit. Would you be able to sort of give us a bit of an overview of what you mean by that?
Yeah, I think there's some very, very tangible examples that are happening right now and will continue to happen, I think, for the next decade or two. So one of the trends that we see across the world is that people are moving from rural areas to urban areas. We call this urbanization. At one end of the scale, one of the most significant outcomes of that is that the number of megacities in the world, so that's cities with 10 million people or more, is forecast to more than double by 2050. So if you can then imagine in a historical footprint of a city or an expanding city, the influx of people, the influx of infrastructure, the requirements for utilities, the requirements for waste management, the whole gamut, all becomes quite focused, if you like, on a very large population, and that is going to multiply and continue over a period of time. So the challenge for engineering, and engineering sits right at the center of enabling this to happen, but also making sure that we deal with the consequences and we create quality of life in these large urban centers over the next many decades, is very obvious in many facets of engineering. The other ones I would point to are, we've talked about decarbonization or climate change and the resulting effects of that we need to put into place around decarbonization. And that cuts through so many of the industrial applications of engineering, so many of the public good applications of engineering. How do we decarbonize? How do we use energy? How do we use fuels in such a way that we don't add to the climate problem and in fact try to reverse the climate problem? The other side of that climate change problem is, of course, that we're already at the point where we're seeing the impacts. And so the vulnerabilities and the resilience that we need to build into our design, into our construction, into our operation of engineering applications increases dramatically as well. It's a different design prospect that we face as we look at resilience against climate change. So these are some, there is no other discipline in the world that I can think of, certainly not lawyers or doctors or teachers or psychologists who are going to be sitting in the middle of that trying to solve it. It is engineers.
That's so interesting. And it brings to that piece of how are we going to do this, right? And as engineers, how are we going to tackle these big challenges? And I think historically we've used the technology at our disposal in practical ways to be able to do this. And so we talk a lot about the intersection between engineering and technology in this podcast, and thinking about some of the things that are coming forward with the backdrop of some of those really major things. It's almost, in my view anyway, it's almost like we need to accelerate the technology, but we need to obviously do it in a responsible way. But certainly what I'm seeing is that with the pace of things such as AI, such as technological change in construction practices, different materials and other things that we're using for the first time, these are sorts of decisions that we're making now in light of the global challenges that we face and where we stand at the center of it. And so I'd love to break down some of the thinking that from your experience and I guess the lifelong lived as an engineer in leadership positions, what are some of those things that we need to consider as we take this fast moving technology into the future and to solve, whether it's solving these problems or creating an abundance for us as mankind or whatever it is in the aspirational sense. But what are some initial thoughts that you have on that?
Look, it's a really good and it's a very big question as well. So as engineers, we are trained. Our classical training, if you like, is to solve a problem, is to put a boundary, a scope around the problem so it's solvable, and then say, okay, within the scope of that problem, let me solve that problem. And it's actually one of our most effective tactics in solving a problem is the ability to break down and subsection a problem and then put it back together again. I think one of the challenges for engineers in the future, and we see it now, is I think a more holistic way of looking at engineering. And I look at engineering leadership, if you like, in three bits. The first bit is that more often than not, we're solving a human problem. We're solving a problem that the solution of which is going to benefit human beings, one or thousands or tens of thousands or millions. Right? And I think understanding, empathizing with the problem intrinsically makes us better engineers. If we only solve the technical problem without understanding the human problem that lies behind it, the why of the problem, not just the what of the problem, I think we limit ourselves as engineering leaders. So the first part of my my little equation is, if you like, is understanding the human nature of the problem. The second part of it is the thing that we're trained in and we're quite adept at doing, which is finding technical solutions, finding technical options to solve that particular problem. And we can find a variety of different ways to solve a problem. Then we go into optimization, which is the best way of solving that problem. The third bit, which I think we often forget, is what is the value of the solution compared to the cost of implementing that solution? What is the economic benefit of doing it this way, right? And so I'm not talking about the lowest cost, or I'm not talking about the option that comes well within budget. I'm talking about what is the value against the human problem of solving it the certain way. So 3 steps. What's a human problem? Do I understand, empathize with it? Will that make me a better engineer? Let me bring my technical genius to the problem to try and solve it. And then let me understand the so what. What are the implications of that? What are the economic implications? Is that viable? Does it have long-range value over short-range cost? Right. So that I think is a more holistic way of thinking that I see engineering leaders adopt more and more forcefully as we move in this technological curve.
Yeah. That's a great principles, and I think simple to think about, but maybe not as simple to implement as well. So in thinking about, I suppose I sit here as a bit of an engineer thinking about some of the technological advances and talking more specifically to AI. And you've probably had a fair few discussions with some of the notable leaders in this space, or other engineering companies, and how they're using it and other things like that. I'd love to get your perspective on AI specifically.
Yep.
And with the light in thinking about it in terms of that human problem, that technical problem, and that value proposition, or however you want to express it, I'd love to hear your view, being able to see it from, I guess, the top of the mountain as such. And although this is a fast-moving technology, it's still very much a tool, but it will change things. What's your view on it?
Well, it most certainly will change things. And, so I'll give you my personal take on AI. I think it's incredibly, incredibly exciting. It has some far-reaching shadows that I can't quite see. And so there are some uncertainties around AI. But I think if I look at AI as a tool, I see its application as, we're just starting the journey of that application, and it's very exciting to see where it will take us. I think as engineers, it has the potential to make us great engineers, much better technologically, much faster at looking at options, at optimizing, at including big data into the problem and its solution. So I think that middle piece of that trifecta I talked about, it just makes us far more potent. As engineers, I would think we ought not to be worried about it, but we ought to be quite excited and embracing of it, but not then neglect the other 2 adjacencies, which are, do I understand the human problem, and what is the economic outcome, or how am I finding the best solution to the problem from an economic perspective as well. So I think, in a way, we've been given as engineers a gift in that middle of the three-pronged approach that I was talking about. But I think we should be wary of not neglecting the other 2 prongs in our excitement around AI, because I think that is the special holistic genius we can bring to the problem as engineers.
Yeah, look, I think history has shown that we're certainly the implementers of the tools, and scientists will obviously they'll do the research and they'll find these groundbreaking technologies that then can be applied, and then seeing that happen. Just a personal note for me as well, and I don't know why this comes to me specifically now, but I realized at a point, it was probably maybe earlier in my career, maybe I was sort of 3 years out and graduate engineer, and I was watching a video of a rocket landing back to the Earth. SpaceX had launched the Falcon Heavy rocket. The boosters had come down and they had landed themselves after boosting up a rocket. I sat there just in awe. I was in the middle of my day and I just was looking at that going, this is incredible, the fact that we can do something like this. And then ever since then, I've just had this reverberation to go, what is possible, And that excitement that you talk about with regards to being able to wield some of this technology is, for me, I really feel that the application of AI, or whether it's machine learning or other things, can really accelerate our good that we can do, but also the capabilities of what we can do, And I think it's right to embrace that. And then I think it's really pertinent to have this discussion is to think of those other two aspects as well.
Yep.
And I think you summed it up so perfectly. And so that's an example for me to go, what is possible, And from there, you can extrapolate, Elon Musk is wanting to do colonies on Mars and other things like that. But where we stand now is a really practical, good example of how we can move this forward.
I like that example that you've brought up. The way I look at AI is it allows us as engineers to create. We talked about scoping and boundary setting as a problem-solving kind of tool, something that we've been taught as classical engineers. I think AI allows us to play with far greater volumes of data in different aspects, including those environmental, those social, those economic aspects. It allows us to be much more multi-parametric over a much wider scope of vision as engineers. And so as a tool, it allows us to create porous boundaries, if you like, around our scoping, our scoping application. We're able to say, we can look at what if this happens. We can look at what if that happens. We can interrogate what ifs at a far greater amplitude than we've ever been able to do before. And so I think if as an engineer we're not embracing AI, I think we're declining the table stakes of being the future engineer.
No, that's so true. I'd love to hear as well your thoughts. I sit here sort of maybe 15 years into my career, eventually having that experience and understanding how things work and being able to do the technical problems and starting to get into things like solving business problems and other such things. And you've obviously had that journey. If you were to sort of maybe be someone in my shoes, similar to my age, again, at this point in time, what would you do? Like, where would you go? It's a tricky question, I know, but I'm winding myself back to kind of looking at, at that stage, what were the crossroads I was looking at and what were the decisions I was making? Look, I recognized early enough in my career, luckily, about externalities, about if you design, construct, operate a piece of asset, an engineering thing, what are the implications it has for people, good and bad, unintended and intended. And so I guess I was able to develop a curiosity, and I would say always be curious. Whatever you're doing in engineering, it sits within a wider system. Even if I design and construct a building in the CBD, it exists within a much, much wider system. And the domino effects of the decisions I make in that wider system reverberate somewhere in that system. So I think understanding, being curious about that I called it a porous boundary, being curious about that. The other thing I did quite mindfully was I figured I didn't really understand much about finance, economics. I kind of understood enough about cost. Like I knew, if I had a budget of $2 million, please don't go over that by more than, $100. I understood that, but I didn't really understand. The implications of finance on engineering, and it dawned on me at the time that
most engineering works have a lot of zeros at the end of it. Now, when you look at a lot of zeros, there's, 5, 6, 7, 8, 9 zeros often. And so if I didn't understand what those zeros meant, where I was going to find the money for those, find those zeros, where am I going to finance? How am I going to finance this? Beyond net present value, how do I understand the economic benefit? If I didn't understand that, I was out of the leadership discussion. I was just the design or construction person in the back room if I couldn't talk to those concepts. So I think, if I wind back to at your stage of my career, those were the tools I try to give myself, not at the expense of my technical expertise. That's a given. I can't depreciate my technical expertise. That's always got to be on point. But how do I invest in the other things? And so I did that quite mindfully.
Yeah, no, that's great. Great advice. And I'm sure there's a lot of those engineers in that stage of their career that are thinking about those sorts of things now, having the opportunities to do different roles like that and thinking about how they'll frame it for themselves. Another question I'd love to hear your perspective on is the executives. So if the executive's sitting there right now leading that initial charge of this technological revolution, if we want to call it that, what would you say to them at this point in time? Obviously, we've talked a lot about different things, but in that context, what would you say to them?
I think it depends on where you want to be. You're an executive, and so as you look forward into your career and the impact you're going to make, I think it kind of depends on what you've got in your head. But let me give you a saying that I heard 25 years ago. Most engineers will become managers. Very few engineers will become leaders. And there's a very subtle distinction between managing and leading. I think of managing as working within a system that's been preordained for you. You optimize working within that system. You get better and better outcomes within the system. I think of leadership as breaking outside of the boundaries of that system and creating innovation, creating surges forward, whether it be in technology or whether it be in the human impact or whether it be in the economic value of what you're working with, but it's surging forward. And so, I would say to executives, think about what it is that turns you on. If it is, I used to work in the energy industry, and if you're operating a power station, and your jam in life is to get your efficiency of your power station up higher and higher and higher by the extra 0.5% and the extra 0.25%, then you're managing a system to optimize. And if that is your jam, that is your jam. You go for that. If you're managing a power station and you're thinking there are better ways to develop energy into the grid, and I'm going to go fool around with some of those, then you're creating new ground. You're experimenting. You're innovating outside of that. And if that's your jam, that you should invest in that. So I'd say be clear about what it is. I ask my kids, what do you want to be doing 5 years from retirement, other than sipping Mai Tais in Hawaii? And it's a hard question for them to answer because it's so far ahead. But if they say, I want to be running thousands of, organizing thousands of people to be doing good in wherever, then I say, okay, cool. Now you've said what you want to do in your career in a very abstract way. Let's work back from that. So I would say to the executive, know what you want to be doing 5 years before retirement. And if that's your jam, that's what you need to invest in.
That's fantastic. I think it really rings true to what impact you want to make in a way. And I think that's really important because when you have the opportunity to either lead others or be able to harness the value or the financial side of things to make decisions on what's going to happen and move forward, it's really important that making those decisions in a prudent and wise way, but with vision as well, is really important, I think. And thinking about that as well, being able to have that financing or funding as well, and putting it into those things that are going to move the needle or move it forward in the right way, For me anyway, I'd love to see a lot more executives thinking about that rather than just driving for more productivity or the bottom line, because we can be more aspirational.
Absolutely.
In our endeavors.
Absolutely.
I think.
I mean, I think, Owen, if you look at, which I did last year, I looked at the ASX 100 and manually counted up all of the CEOs that were engineers in the ASX 100. And then I was curious, so other than what sort of engineering did they do, I was curious, what else did they do? And at the point that I did the data analysis, over 85% of the engineers who were CEOs in the ASX 100 had done some form of financial postgrad qualification. They'd actually said, the money matters, and I'm going to invest myself in it and understand it. So I don't think that's a coincidence. I think that's a trend.
Oh, for sure. And I think whether it's the capital, whether it's personal ambition, and whether it's like the direction that we're taking, I think having all of these things we've talked about as a bit of a backdrop to make the right decisions moving forward, because it's going to move faster than ever. It's going to move so fast, and we just have to be able to continue to catch that wave, whether you're on the surfboard or whether you're swimming with the sharks or whatever you want to call it. I think that lays a great foundation. I'd love to hear a bit more about Engineers Australia as well, and your role there as President of Engineers Australia.
Sure.
And I suppose as the president, what do you hope to influence during your term in serving as the President of Engineers Australia?
That's a pretty long list, Owen. How long is the podcast?
Oh yeah, it's about 40 minutes, but
look,
I'll strap in.
It is a long list. So let me start with the highest level that I'm thinking about. One of the things I hope to influence is, and we've started doing this in Engineers Australia, is to connect the value of engineering to the economic well-being of Australia. And I think enough people have heard me say enough times that just 5 of the sectors that drive our GDP are all engineering heavy, mining, manufacturing, construction, professional services, energy, water, and waste, make up nearly half of our GDP, right? And I think that's surprising to many people when they first hear that statistic. And it's not a one-off statistic. It's something that's been a part of our GDP for many, many years. We are inherently an engineering-oriented country. So really to drive home the worthiness of investing in technology, in engineering in Australia, to be able to give us a competitive advantage in the world, a world that comprises over 190 countries with very disruptive and disrupting supply chains. How do we create our own sovereign strength through the adoption of engineering and technology? And it's important to acknowledge, you made a point before about science and engineering. Science is discovery-based, I think, and engineering is scaling up and scaling out. Engineering takes that scientific discovery and makes it adopted, accessible to thousands, hundreds of thousands, and millions of people. That is what it does. So it takes a gem and it creates this immense value across a broader ecosystem. So the ability for Australia to invest in that strength as a sovereign attribute that would give us greater social and socioeconomic strength in a world economy. I think so. That's one of the highest things I speak to. And when I say investment, that comes in many, many forms about generating both the talent, the people in engineering, but also the knowledge, the systems in engineering in Australia, but also the connectivity between our sectors. For example, the missing link in our sectoral relationship, we dig metals out of the ground. We have a very small manufacturing base, so we can't create much value out of those metals. And so we export, then import back value-added products to generate our own value, if you like, in infrastructure or in building or in decarbonization. Right? So we have a gap that we can fill. in engineering. So that's at the highest level. At a more fundamental level, what I hope to change is the vision of young engineers. I think seeing their future as being many, many faceted, many options available to them, and a growing structure and interconnectivity of different engineering. So if I'm a civil engineer, it doesn't mean I'm a civil engineer for life. I become an engineer that can do many, many other things. How do we sort of trigger that vision? I'm going on a little bit, but one more on this is that the term engineer has been associated with problem solving, which is a good thing because that's what we're very good at. But it carries connotations of fixing something. It's a fixer type connotation. Whereas I think there is greater imagination to be gained from particularly young students at school, seeing engineering as the creation of enablement for humanity. So I'm not fixing the train. I'm creating the next mode of transport. It's really taking us out of that old-fashioned thinking of what an engineer is and does in the public discourse and putting that up there with the creation of futures.
Well, that's great. And I've been sort of inspired by the work that you've been doing there as the president and obviously being a part of the organisation for a long time. So thank you for all the work that you're doing there.
Oh, thank you.
We really appreciate it.
That's very kind of you. Thank you.
To finish up, I'd like to hand you over to the AI host. He'll summarise and he'll ask a little bit of a question. And so I'll just go ahead and do that. So I'll hand you over now to the AI host.
In every conversation about engineering leadership, there's a thread that ties back to responsibility and vision. Today, we uncovered how the role of engineers is evolving, not just to solve technical problems, but to shape a sustainable and human-centered future. We explored how global challenges require local leaders with a mindset that blends empathy, technology, and economics. Raj, if there was one habit or mindset shift you could inspire in the next generation of engineers, what would it be?
Great question. And if I can quote another great AI back at you, there is no future but what we make. And what I would say to engineers is think about how you set the problem, how you scope the problem. It has served me well over many years to think of the boundary setting as a porous boundary, that I'm curious about externalities. I'm curious about the human impact of what I'm solving or what I'm applying myself to, the economic consequences of that, the environmental impacts, the environmental vulnerabilities, the long-term, the short-term, the political implications of what I'm thinking about. And so I would say to engineers, embrace that porous boundary. Think beyond it, envisage beyond it. In fact, at the risk of displeasing some of the old university lecturers, break down some of those old paradigms about scoping things. Stop saying this is not within scope. Embrace a broader scope.
That's a powerful piece of advice, and it really captures the essence of what we've been discussing. That true leadership in engineering means not just staying within our defined scopes, but also looking beyond them to see the bigger picture. It's about expanding our perspective and embracing those broader responsibilities. So if this conversation sparked your curiosity, keep tuning in. We've got plenty more to uncover about what it means to lead with insight and integrity in the modern engineering world.
Thank you there, Mr. AI host.
Very pithy.
Very good, very good. I've really enjoyed the conversation we've had today, Raj.
So have I.
For your experience and for your vision and insight, but also to really hit on some of those topics that, with the rush of the new technological changes, which allows us to think of the decisions that we need to make, where we can put our best efforts, where we can put our best investment as well. So thank you for that. Is there any final words that you'd like to share with us before we finish up?
No, I think I've really enjoyed having this chat with you, and just in a reciprocal way, I have just listening to AI summarize that thing, which is quite new to me. I think I haven't heard that before. It's actually sparked some further thoughts in me. That's thank you for the opportunity to chat about this.
Yeah, no, thank you, Raj, again. So if this episode got your thinking about leadership beyond your tools, then connect with me on LinkedIn. I love hearing how engineers are expanding their impact and rethinking of their role in society. We'll link to Raj's work in his book, Leading Tomorrow and Other Such Things, and his engineering, his role as in Engineers Australia as the president. And if you found value here, please follow or share the podcast with a colleague. The world needs more engineers who lead people with principle, purpose, and perspective. Until next time, stay curious, and thanks again, Raj.
Thank you, Owen.